Welcome to another A-Level Maths video. This is Mr. Hegarty here, and in this video we're going to talk about integration, and we're going to use the technique of integration by substitution. So what we'd like to do in this video, we'd like to integrate functions by making a substitution of variables. So when this occurs, this usually occurs when we've tried various other methods and we can't make them work. We can't, for example, do it by inspection, and it's not a standard integral, and we try a substitution of variables. Usually you're told what substitution to do. So the best way to do these is by way of an example. It's the easiest way to explain. Now we're told here, use the substitution u is equal to 2x add 5 to integrate the following. Now this is the aim. The aim is to replace every x in here, that x, and this dx, with something with a u in it, with u's. That's the aim of the game, to replace all our variables with x with u's. Now we are told that u is equal to 2x add 5. Now what you do with these questions, the first thing you do is you differentiate both sides with respect to x. You work out du by dx. Du by dx is going to equal 2 in this case. Okay, so making dx the subject, we can think of this now as a fraction, and making dx the subject of the formula, multiply both sides by dx and divide by 2, we would have that du divided by 2 is equal to dx. Now why do I want that? Well, I want to replace this dx here with du's, something with u's in it, and I've got an expression for dx, so I'm done in that regard. Also, I can replace the 2x add 5 square root with the square root of u, but what can I replace the x by? So after you've worked out dx, the next step is to make x the subject of the formula. So in this case, because u is equal to 2x add 5, if I was to make x the subject of this formula, I would take away 5 and divide by 2. So x is equal to u take away 5 divided by 2. Okay, so let's change our integral then. What we're trying to integrate, so that was our working. What we're trying to integrate x and 2x add 5 square root, which I'm going to write as to the power of half dx. And I can replace this x, so I can instead integrate, well, x is u take away 5 over 2, so u take away 5 over 2. 2x add 5 to the half, well, u is equal to 2x add 5, so that would just be u to the power of a half. And dx, we worked out, is du over 2. So we'd have du over 2, like that. And then we can just do a bit of tidying up. There's a half here and a half here, which multiply to give a quarter, which we could take out at the front of the integral, so I'd have a quarter. I'd have the integral of u take away 5 multiplied by u to the power of a half du. I can expand that bracket, so that would be a quarter. The integral of u, that's to the power of 1. U to the 1 multiplied by u to the half is u to the 3 over 2. Take away 5u to the half with respect to u. Now let's do the integral, so keep the quarter there. These are just polynomials. So add 1 to the power and divide, so it would be 2/5 u to the 5 over 2. Take away, add 1 to the power and divide, so it would be 5 divided by 3 over 2, so 5 divided by 3 over 2, we get 10 over 3, so this would be subtract 10 over 3 u to the power of 3 over 2 plus your constant. Okay, so tidying that up, that would be a quarter times 2/5 would be equal to a 10th u to the power of 5 over 2. Subtract a quarter times this, which would be equal to 5/6 u to the power of 3 over 2, add constant. So that is my answer. Now, it's very important at the very last step you do this. The whole thing was in terms of x's, and you've given your answer in terms of u's. At the very end, give your answer back in terms of x's. So that's a 10th. Well, what did we define u to be? 2x plus 5. So it'd be a 10th, 2x add 5 to the power of 5 over 2. Subtract 5/6, 2x add 5 to the power of 3 over 2. Add your constant c. So that is your final answer there, and we're done. So let's just reiterate the steps. You're told the substitution, okay? So wherever you see 2x add 5, put u in its place. You then work out dx in terms of du by differentiating this with respect to x and rearranging. And then you make x the subject of the formula so that wherever you see x on its own, you can replace it with something with u's in it. You work out the integral, then you replace everything, do the integral, which now you can do, and at the very last step, put back in your x's in place. Right, let's have a go at another one. Use the substitution u is equal to sine x plus 1 to find this following integral here. So, we've got u is equal to sine x add 1. The first thing I'm going to do is find dx as the subject of the formula. So differentiating both sides with respect to x, du by dx would be equal to cosine x. Okay, so therefore dx, making that the subject, multiplying by dx and dividing by cos x would be du divided by cos x, like that. Okay, now, at this stage, sometimes it's fine to leave your answer like that and not put it in terms of u's. The reason why is when I replace this dx here, can you imagine replacing it by du over cosine x? That cosine will divide by that cosine and they will cancel each other out. So it's fine, I can have a bit of foresight and think that's fine to leave it like that just at this point in time. Okay? Let's look up at the thing we're trying to integrate. We've already had some foresight and seen that that cos x will cancel with the cos x I've got from here. So I'm not worried about that. We've got 1 plus sine x cubed, which I can replace by u cubed. The only thing I need to think about is what is sine x. Well, from here, I can make sine x the subject. I can state that sine x would clearly be u take away 1. So now I've got that covered, and this covered, and that covered. So I'm ready to do the integration. So what am I trying to integrate? Well, I'm trying to integrate the cosine of x multiplied by the sine of x, 1 add the sine of x, all cubed with respect to x. And let's do this. Let's leave the cosine there for now. The cosine x, the sine x we said is u take away 1. The 1 plus sine x cubed would be u cubed, so that would be u cubed. And dx we said was du over cos x, so du over cos x, and we've replaced everything. So just tidying up, obviously these dx's cancel each other out, so this is equal to the integral of u subtract 1 multiplied by u cubed with respect to u. I can expand these brackets, so that's the integral of u to the power of 4 take away u cubed du. Now I can do the integral, so it would be a fifth u to the power of 5 take away a quarter u to the power of 4 plus a constant. And at the very end, I have to substitute back in terms of my signs. Now u was sine x plus 1, so I'm going to substitute back in and say that's a fifth sine x add 1 to the power of 5 take away a quarter sine x add 1 to the power of 4 plus your constant, and I'm done like that. Okay, so let's have a go at another one. Now, look at example 3. That's very like my first example. In fact, it's the same question. However, I'm given a different substitution to do here, a different way of substituting. In the previous example, I substituted u is equal to 2x add 5, didn't I? I substituted u is equal to 2x add 5, yeah I did, but here I'm using the substitution u squared is equal to 2x add 5. And I just want to show you that sometimes you're given the substitution in that form, what do you do? So we know that u squared is equal to 2x add 5. Now I want to differentiate both sides with respect to x, so I want to differentiate both sides with respect to x as I normally do. Like that. Now you just have to be a tiny bit careful when doing this. This is implicit differentiation, which you will have seen in chapter 4. So when you differentiate this, you would differentiate it with respect to u and get 2u and post multiply it by du by dx, like that. And this just differentiates as normal as 2. Okay, so I'm making dx the subject of the formula here, so multiplying by dx, 2u du is equal to 2 dx, and dividing by 2, u du is equal to dx. So I can now replace the dx with u du, and everything else I should be able to replace. I can replace this with u squared, square rooted, and obviously what's x as the subject of this formula? Well, x as the subject of this formula, if we know that, let's just do it in a different colour pen, u squared is equal to 2x add 5, then x would be u squared take away 5 over 2. That would be equal to x. So now I'm ready to do my substitution. So what was I integrating? I was integrating x, the square root of 2x add 5. So x, 2x add 5 square rooted, like that, with respect to x. Now x I'm going to instead replace with u squared take away 5 over 2, u squared take away 5 over 2. The square root of 2x add 5, well 2x add 5 I've called u squared, so the square root of u squared is simply u, and dx I'm now replacing with another u du. Okay, so I can take the factor of a half out, so I'll take the half out there, and I've got the integral of u squared take away 5 multiplied by u squared du, and that's going to be equal to a half the integral of u to the power of 4 take away 5 u squared du. And now I can perform the integration, so that's a half, and here I'd have a fifth u to the power of 5 take away 5 thirds u to the power of 3 plus a constant. Multiplying out, it would be a tenth u to the power of 5 take away 5 sixths u to the power of 3 plus a constant, and replacing back your u's, well, if u squared is equal to 2x plus 5, then u would be the square root of this, which is 2x add 5 to the power of a half. So replacing our u's here, this would be a tenth, okay? U is 2x add 5 to the half, so this would be 2x add 5 to the half to the 5, which would be to the 5 over 2, take away 5 6, 2x add 5 to the half to the 3, which would be to the 3 over 2 plus constant. And if we look back at our previous answer, you have a 10, 2x add 5 to the 5 over 2, subtract 5 6, 2x add 5 to the 3 over 2, and here we have exactly the same thing. So there were two different ways about going about the same problem. In this case, we were given a different substitution to use. Okay, in all the previous cases, let's just look back at our three examples. We were asked to do an integral and we used substitution, but all of these were indefinite integrals. And by that, I mean there was no limits here. There was no limits. In example 1, in example 2, there was no limits, and in example 3, there was no limits either here. Now what we need to do is to consider ones where there are limits. For example, here. There are limits here. Now it's the same process. The only thing is these are x limits, so we need to change them into u limits. So we do the exact same thing. So this time we're not given the thing to substitute, but always substitute the most complicated expression. So what I'm going to do is I'm going to let u be equal to x add 1. So I'm going to let u equal x add 1. Okay, and then we're going to work out du by dx. Du by dx would be equal to 1, so du is equal to dx. So I can replace dx with du. Okay, now I've got x add 1, I can replace that x add 1 cubed by u cubed. Let's make x the subject of the formula for the second part, so that will get us our first set of marks. The second set of marks, if u is equal to x add 1, then clearly x as the subject is u take away 1. That would get us our next set of marks. And the last thing we have to do is change the limits. So for step number 3, which I'll do in red, we know that x is equal to 0. So when x is equal to 0, u, which is x add 1, would be 0 add 1, so u would equal 1. And when x is equal to 2, u, which is equal to x add 1, would be 2 add 1, which is 3. so we can change our limits as well. So it's very important you remember to change the limits. So the integral we're trying to do is the integral between 2 and 0, x add 1 cubed with respect to x. So we're going to replace this, I'm going to do it in a different colour, with the x limit of 0. When x is 0, u is 1, so I'm going to put 1 there. And when x is 2, u is 3, so I'm going to put 3 there. X, we've said, is u subtract 1, so I'm going to replace that with u subtract 1. X add 1 cubed is going to be u cubed, and we can replace dx with du. And there we go, we're ready to continue this question. So expand the brackets, so the integral between 3 and 1 of u to the power of 4 subtract u cubed with respect to u, and then we integrate this, so it's a fifth u to the power of 5 take away a quarter u to the power of 4. Now in this case we don't have a c, it's a definite integral, we have limits. All we do is we substitute in the values straight away. We don't have to convert back in terms of x because we have changed our limits to u limits. So we put in a third. So what we do is I would use my calculator and write a fifth. I'm going to write in terms of x to the power of 5 take away a quarter x to the power of 4. And I'm going to work that out at 3, so I get 5, 6, 7 over 20, so it'd be 5, 6, 7 over 20, and I'm going to take off the answer when I put 1 in, so I'm going to put in 1 and take off negative 120, like that. So then what I'm going to do is I'm going to say 5, 6, 7 over 20, and I'm subtracting negative that, so it's like adding 1/20th, so adding 1/20th, and I get 142 over 5. And 142 over 5 is 28.4, so I get 142 over 5, or 28.4, like that. And that was integration by substitution and changing the limits. Okay, last one, a trigonometric one with limits in it. And we're not told our substitution, but let's make the thing underneath the square root my substitution. So what I'm going to do is I'm going to let u is equal to 1 add sine x, like that. And I'm going to differentiate both sides with respect to x. So du by dx is going to equal cosine x. So dx as the subject is going to equal to cosine x. Dx as the subject is going to be du divided by cosine x. Now, when I replace this dx by du over cosine, you can see the cosines cancel, so I'm not worried about the cosine here. I know it's going to cancel when I replace this. Okay, so that's fine. I've got an expression for 1 plus sine x, it's u to the half. The only thing I need to do is change the limits. So when x is equal to 0, in our case we start with x is 0, then u is equal to 1 plus sine 0, which is 1. When x on the other hand is equal to pi by 2, u is going to equal 1 plus sine of pi by 2, and sine of pi by 2 is 1, so it's going to be 2. So I'm ready to change my integral around. So I'm integrating between 0 and pi by 2 of cosine x, 1 plus sine x dx, and I think it's to the power of a half. Yeah, it's going to be to the power of a half. So I'm going to do a replacement. I'm going to replace that by the integral, not at 0 but at 1, and not to pi by 2 but to 2. The cos x, I'm going to leave there for now, the cos x. 1 plus sine x is going to be u to the power of a half, and dx is going to be du over cosine x. And the cosine x's cancel. That's why I didn't worry about them too much when doing this question. So this is the integral between 1 and 2 of u to the half du, which is add 1 to the power and divide, so it would be 2/3 u to the 3 over 2 in between 2 and 1. So when I do that, so I can get the calculator out and I can go 2/3 x to the power of 3 over 2, and I could substitute in when x is 2. Well, actually, it's giving me decimal answers here, so let's just actually work this out. I'm going to take the factor of 2/3 out, if you don't mind. It doesn't matter. U to the 3 over 2 to the power of 2 and 1. And what I'm going to do is keep the 2/3 there, put 2 in, so it would be equal to 2 to the power of 3 over 2, subtract 1 to the power of 3 over 2, and that's 2/3. Now that would be 2 cubed, which is 8, and then square rooted, so it's going to be the square root of 8, take away this thing is obviously 1. And writing square root of 8 is in simplest form, square root of 8 is square root of 4, square root 2, which is 2 root 2. So I could write that as 2/3, 2 root 2, take away 1, and I'm done. Now, there was no need to change back in terms of x's. Because I changed the limits, working out gave me the exact answer. Okay, and that's it for this video. So all I'll say about integration by substitution is that one, the substitution is usually given. Substitution usually given. And if not, let u equal complex x function. Okay, the complicated bit of the x function. And secondly, the thing is, if it's indefinite, if it's an indefinite integral, you must at the end change back in terms of x, change back in terms of x, okay, at the end. And if it's a definite integral with limits, if it's a definite integral, well, you don't have to do that, but what you must do is you must change the limits. You must remember to change the limits from x limits to u limits. Okay, and that's all we need to talk about in this video. Make sure you do the following in order to consolidate that learning. Thanks for watching.